So, if you were told to find the cosine of pi over 4, what is the cosine of pi over 4 from a unit circle? Square root of 2 over 2. If you were told to find the decimal equivalent of that, what would you do? Put it into your calculator. Take the cosine, or take square root of 2, press equals, then divided by 2. Because if you take the square root of 2 divided by 2, it'll give you 1. Because you're not doing it in the right order. Order of operations is important. So the square root of 2 press equals is 1.7 something. Or 1.3 something. I forget what it is. No. Yeah, whatever. And then if you divide by 2, what do you get? What's the square root of 2 over 2? 0.7074? So you will have to make some decimal equivalents today when you're graphing. So you'll find the value of it, and then you'll have to make some decimal equivalents. Now, we're going to work this chapter on taking a graph that might look like this. Wow, that was cool. See if I can do that again. It thinks it's wanting me to erase. Okay, you'll take a graph like this. If we move it this way, or if we move it this way, or if we move it up, or if we move it down, or if we stretch or shrink or whatever, we're going to be doing that a lot this chapter. Those of you who have already taken Algebra 2, the translating graphs. Yeah, that's the word I was looking for. Translating graphs, that's what we'll do. So, if we have a point at like 2, 4, and we slide 3 to the right, where does it become? It goes to 5, 4. You slid it 3 up there, Mr. Wolf. Okay? But in trig, we'll have something like pi over 2, 4. And we'll slide pi over 4 to the right. Okay? So if we're going to the right, we have to add it to the x variable, correct? So if we're sliding pi over 4, we take pi over 2 plus pi over 4. But we can't add fractions like that. We need a common denominator. So we'll have to multiply this one by 2 over 2. So we have 2 pi over 4 plus 1 pi over 4, which equals 3 pi over 4. So if we slide pi over 4 to the right, it's 3 pi over 4, 4. Okay? We don't change the y value if we're sliding to the right or left. We just change the x value. So if we're at pi over 6, 2, and we're going to slide pi over 3 to the left and 3 down. Okay? The left affects the x, the down affects the y. Okay? Pi over 3 to the left, are we going to add or subtract? Subtract. So we take pi over 6 minus pi over 3, which is really pi over 6 minus what over 6? 2 pi over 6, which gives us what? What's 1 pi over 6 minus 2 pi over 6? Negative 1 pi over 6. And then obviously 2 minus 3 is negative 1. So if we do the math, we get negative pi over 6, negative 1. Okay. So we're going to be doing some transforming of points. And then when we get to the second half of today, then we'll start doing some transforming of graphs. But we're just going to play with points in the first half. Now, the last thing that we're going to do before I give you a short little assignment is find a point halfway between. Let's find a point halfway between pi over 4 and 5 pi over 4, 2, and 6. What's halfway in between pi over 4 and 5 pi over 4? To find a point halfway, we add them up and divide by 2. Okay? 1 pi over 4 plus 5 pi over 4 is 6 pi over 4. 6 pi over 4 divided by 2 is halfway in between is 3 pi over 4. Halfway in between 2 and 6 is 4. That's a point halfway in between. Okay? So let's make it a little bit tougher. Negative pi over 3, negative 1, pi over 2, 5. What point is halfway in between there? Well, you add them up and divide by 2, right? If you add these up, negative pi over 3 plus pi over 2, what's common denominator? 6. So it's 2 pi over 6 negative plus pi over 2, 3 pi over 6 positive. Gives me pi over 6, but we have to divide that by 2. What's pi over 6 divided by 2? Is it pi over 3 or pi over 12? When you divide by 2, it's the same as multiplying by 1/2, if you remember your math rules from elementary school. Dividing by a whole number means that you multiply by this fraction. So you get pi over 12, when what's halfway in between negative 1 and 5? Negative 1 plus 5 is 4, divided by 2 is 2. Okay, let's see if we can figure this out. Your assignment, first assignment, is 11 through 47, every other odd. So the first problem you'll do is, no, 11. The second problem that you'll do is 15. Because we're doing every other odd numbered problem. So it's 11, then 15, then we skip 17 and go to 19, and so on. So 11 through 47, every other odd. So every fourth problem. Do that, and then we'll talk about the next section here in about 15 minutes. 11 through 47, every other odd.